In part one of two videos on the real number system, we will explore the most simple and basic sets of the real number system, being the natural numbers, the whole numbers, and the integers. Before we go over the subsets of the real numbers, let's think about what it means to be a mathematical object to begin with. Let's think about this. Is a phone number a mathematical object? Would it make sense to take your phone number and subtract it from another person's phone number? Could you put phone numbers in any type of order? Would you be able to find the average of 5 different phone numbers? Would any of those things make sense to us in the real world or have any value? The answer is no. So let's put things together. These symbols that we use in mathematics are also used in other areas as identifiers. They're not always used as mathematical objects. In order for mathematics to be occurring, we need these symbols or objects to go along with operations and a set of properties. So when we talk about objects or symbols, we have our number system that we currently use, but many other cultures use different symbols. One that we may be familiar with is Roman numerals, as I've shown here at the end of my list. Operations, of course, are addition, subtraction. We can talk about square roots or fraction bars. Properties are greater than, less than, and so forth. So we need those things to be happening in order to be considered mathematics. Now let's use the history of mathematics to go through and figure out how these different sets of numbers came about. So if you were asked to think about some of the first examples of the use of mathematics in different cultures, one of the things you would come up with quickly would be counting. You've heard of counting sheep. These early cultures didn't have formal writing systems, so they used objects like stones or pictures on walls to keep track of things that were very important to them. So it makes sense that the most basic set of numbers is dealing with counting, or called the counting numbers. The more formal name for the set is called the natural numbers, and we'll use the letter N to indicate this set going forward. So we will use this set not only to count 1, 2, 3, 4, and so forth. We will rank things: first place, second place, third place, and ordering we can obviously make sense of for races or different things, but we've also come up with our calendar system using these ideas as well. So as cultures became more structured, you can see some of the earlier forms of writing in mathematics dealt with tallying. The Babylonians, the Egyptians, and the Mayans all had a certain tallying system to keep track of quantities. Only the Greeks and the ancient Chinese had symbols that represented larger quantities. Now, an interesting thing that a lot of people don't realize is for these earlier counting cultures, we did not have a symbol for zero. If you had cows or sheep, you didn't have to say, I have 0 sheep. I could just say, I have no sheep. So for many of these cultures, they did not come up with a symbol for 0 for thousands of years after they came up with these counting symbols. And that brings us to our next set of numbers. This name did not come about too much later in history, but adding that number 0 creates a new set of numbers called the whole numbers, indicated by the letter W. So we have our natural numbers plus 0 representing the whole numbers. Now, 0 obviously represents nothing, but it also is very important in our modern number system because it acts as a placeholder. It allows us to tell the difference between 101, 110, and the number 11. It allows us to have the difference between the tens, the ones, and the thousands place. Now, as our number system continued to grow, so too did culture. Now, as larger cultures began to demand more and more across the world, our travel and transportation of goods and services were very important. And that brought about having to have a common language and a common notation for a lot of cultures in the world to work together. So you think about where in the world was the major trade hub, a communication center that brought a lot of cultures together, and that was in India, where many people were trading goods. So it makes sense that our number system that most of our cultures use is from the Hindu-Arabic background, because they had to communicate, they had to arrange goods and work together. So you can see the Hindu and Hindu-Arabic is derived over time, and people are trading goods and communicating, and they have a common system that is developed into what we have now. Now, how does that relate to our next set of numbers? When we are purchasing and selling goods, you always aren't going to have an equal trade. So that brings into the concept of debt. When we think of debt in mathematics, we think of negative numbers. Now, just like the name whole numbers, the name integers is something more modern and has evolved over time into what it has become today. This set is made up of 0, the positive natural numbers, and their opposites. So we can think of all the numbers on our number line that we learned earlier in arithmetic as our integers. Please note that this symbol Z is used for the integers because the letter I will be used again for a later set. This concept of negative is not only applied to money and debt, but we use it a lot in science for different types of forces, direction, and other concepts. In addition to looking at our number line, we can also think of a Venn diagram as a way to indicate the relationship between these numbers. So if you think about a box containing all integers, that would be the blue area shown on the screen here with all of the negatives, 0, and the positives. Inside that box is the set of whole numbers. You can make that a red box, and the only difference between the set of whole numbers and the set of natural numbers is the number 0. Within that box for whole numbers, we have another white box in this case indicating our counting numbers or our natural numbers. So this is a good way to display the relationship between our first three sets of numbers. Now, if we only had to do addition, subtraction, and multiplication, these three sets of numbers would be sufficient enough for our work. But unfortunately, we need to divide our values into smaller parts, and that involves fractions and decimals and other operations. So we will have to introduce a few other sets of numbers as we go forward here in part 2 of our study of the real number system. So that's it. Please look forward to part 2 of this video set on the real number system, where I'll introduce the rational and the irrational numbers and finish off the entire set as the real numbers. Thank you so much for watching. Please continue to visit my channel for more ideas on number sense, arithmetic, algebra, and other topics.